Anthropic just did the thing everyone in AI has been waiting to see. It went after the agent race from two directions at once, with a new flagship model and a science product built to turn research into a workflow. Welcome back to Midnight Signal AI. It's July 1st, 2026.
Today we've got that Anthropic double shot, plus Google's new agent tooling for Go developers, and a fresh OpenAI rollout that raises the stakes around access and safety. A lot of motion and a lot of competition over who gets to define the next serious AI stack.
Let's start with the model, because that one sets the tone for everything else.
The big signal here is not just that Anthropic has another model. It's that Sonnet is being positioned as the practical one, the thing teams can actually run all day without paying flagship prices every time an agent thinks out loud. That matters because in agentic work, cost becomes product. If the model is good enough for coding, support, research, and back-office automation, the cheapest model with near-top performance can become the default.
And the reporting around it is all pointing in the same direction. Anthropic is trying to make Sonnet the workhorse while keeping the very top end for the hardest jobs. The outlets around the launch, TechCrunch, VentureBeat, Engadget, and Reuters, all framed it as a move to win the fight for cheaper automation, not just prettier benchmark charts.
That's the smart play if your buyers are enterprises. They don't ask, is it the absolute best in a vacuum? They ask, can we deploy it at scale, safely, and without blowing up the budget? And once a model gets associated with reliable, lower-cost agents, it can start pulling in everything from internal co-pilots to customer-facing workflows.
Anthropic also seems to be pairing the launch with distribution moves. The same wave of coverage says Claude is now showing up in Microsoft Foundry on Azure, which is important because availability often matters as much as raw quality in these enterprise battles.
Right, because the model story only becomes a platform story if it's easy to buy. If Claude is sitting inside the cloud tooling people already use, that cuts friction fast. And that's where the competitive pressure lands on OpenAI and Google, not just who has the smartest model, but who can become the easiest default for real work.
Speaking of real work, Anthropic also pushed something even more specific than a general-purpose model.
This one feels bigger than a feature launch. Anthropic is saying pretty plainly that science is a first-class product category for them, not an experiment on the side. And the comparison to Claude Code is doing a lot of work here. If Claude Code changed how engineers think about day-to-day software tasks, Claude Science is trying to do the same thing for scientists. One high-level prompt, then the system helps drive the workflow.
MIT Technology Review said Anthropic announced it at an event for pharmaceutical executives, biotech founders, and researchers, which tells you exactly who the company wants in the room. It also reported that Anthropic plans to use the product in its own research into rare, neglected diseases.
That's a strong positioning move. If you're building for pharma, it helps to show you're not only selling to the sector, you're using the tool in-house on problems with obvious public benefit framing. It also hints that Anthropic is chasing revenue outside the generic assistant market, where the competition is brutal and the differentiation disappears fast.
Reuters, Stat, and HPC Wire all lined up on the same core point. This is now available, and it's aimed squarely at scientific work, especially computational biology and drug development. Some reporting even described it as a standalone product rather than a plug-in layer.
That distinction matters because standalone products are how you build habits. Plugins are useful, but products create workflows. If this gets traction, the next battleground is probably integration with lab software, internal knowledge bases, and the compliance layers pharma teams need before they trust an AI system with anything serious.
Switching gears, Google had a quieter but very important launch for builders working on multi-agent systems.
This is the kind of release that can get overlooked because it's a developer framework, not a flashy demo. But in practice, tooling decides what teams can actually ship. Graph-based workflows, human-in-the-loop controls, retries, shared telemetry, that's the plumbing that makes agents less like a prototype and more like software.
And because it's in Go, Google is making a pretty specific bet on a class of teams that care about performance, services, and production discipline. That's not just hobbyist agent building, that's infrastructure-minded engineering.
Exactly. It reads like Google wants to lower the barrier for multi-agent systems without forcing developers to stitch together 5 different pieces themselves. If it lands, the win is less about headlines and more about mindshare. A developer starts in ADK, stays in ADK, and builds the whole workflow there.
Now to OpenAI, where the story is less about a broad consumer splash and more about how frontier access is being managed.
What stands out is the pattern. It's not just here's a model anymore. It's here's a model and here's who gets to see it when. That changes how people think about frontier releases. The release itself is now part product launch, part security event, part policy negotiation.
And the cyber attack protection framing is telling. OpenAI is clearly trying to make the case that limited access isn't weakness, it's responsible shipping for a dangerous capability tier.
The trade-off is obvious, though. If you slow public access too much, you give competitors room to frame themselves as the faster, more open option. But if governments and large enterprises want tighter controls, OpenAI might be betting on trust is worth more than pure speed.
Finally, Google had a separate consumer and API-style launch that pushes its image stack and its video tooling forward at the same time.
This feels like Google leaning into a very practical message. If you want fast creative output, here's a lighter weight path. And if you want video generation in your app, here's the API route. That's how you build ecosystem gravity, not one giant model announcement, but a family of tools that cover different jobs.
And it's also another reminder that the frontier race isn't just about chat anymore. It's about who can span assistance, code, science, and media without making developers stitch the world together themselves. Before we close things out, a few quick signals from beyond today's headlines. Now, let's shift gears to robotics. This one asks a pretty big question. Do you really need demonstrations and task-specific fine-tuning for a robot to be useful, or can a general LLM agent take the wheel? The paper's answer is a serious attempt at the second option. It wraps an embodied manipulation system in the same kind of frontier agent logic people use for coding and software tasks, then lets that agent plan, act, and recover using structured steps instead of a pile of handcrafted robot training data.
That is a wild crossover. If it works even halfway well, it changes the economics of robotics training pretty dramatically because demonstrations are expensive and they age fast when the environment changes.
Exactly, and that's the real story here. Robots live in messy spaces. Lighting shifts, objects move, grippers slip, and the last mile is often where a polished benchmark model falls apart. A general agentic controller could help a robot reason through surprises instead of just repeating a learned motion pattern. The caveat, of course, is that embodied systems have to be right in the physical world, not just plausible in text. So this is less about replacing robotics research overnight and more about opening a new control stack to test seriously.
And if the agent can recover from errors on the fly, that might matter more than raw peak performance. In robotics, resilience is often the whole game.
Yeah, if this line keeps maturing, the big win won't just be better demos. It'll be robots that can adapt when the job stops looking like the training set. On the medical front, the interesting angle isn't a diagnosis model or a drug discovery headline, it's security. This paper applies the TRISM framework, meaning trust, risk, and security management, to an agentic healthcare workflow for generating medical reports. The pitch is simple but important. When you give an AI tools and permissions, you often give it more access than a normal user would have, and in healthcare, that can become a privacy, compliance, and safety headache very quickly.
Right, because in medicine, the issue isn't only whether the model is smart enough, it's whether the workflow is defensible when real patient data is involved.
Exactly. Agent systems are tempting in clinics because they can draft, retrieve, summarize, and route work fast, but the more capable they are, the more they need guardrails around data exposure, privilege boundaries, and audit trails. What I like about this one is that it treats safety as part of the design, not an afterthought. That matters if healthcare AI is going to move from demo-friendly notebooks into actual hospital infrastructure.
And it sounds like a reminder that the winning healthcare stack may be the one that can prove what it did, not just do it.
That's the bar. In medicine, trustworthy automation has to be traceable automation. Over in the silicon world, this is a neat blend of AI and systems research. MetalSci is a benchmark for scientific compute kernels on Apple Silicon, and the twist is that it pairs the benchmark with an automatic kernel search harness. So instead of just measuring speed, it asks whether an LLM-assisted system can actually discover better GPU or accelerator kernels for real scientific workloads, like stencils, FFTs, N-body problems, and molecular dynamics.
That feels very practical. Once you start talking about runtime compiling candidate kernels and scoring them, you're in the world where tiny gains can add up fast.
Absolutely. And the benchmark structure matters because systems people need something reproducible, a CPU reference, a roofline-style fitness function, and held-out sizes to check generalization. That gives the model search process a real target instead of a fuzzy benchmark score. It also keeps the conversation grounded in hardware realities, bandwidth, compute ceilings, and whether a generated kernel actually respects the machine it's running on.
So this is less AI writes magic code and more AI is becoming a tool for serious performance engineering.
Exactly. The fun part is that the better this gets, the more the bottleneck shifts from guessing kernels to understanding which workloads are worth searching in the first place. And to end on a lighter note, here's a delightfully nerdy question with surprisingly real consequences. If you patch a model with knowledge editing, can later fine-tuning wipe that patch away? This paper looks at the fragile coexistence between editing and adaptation, and it turns out that's not just an academic curiosity. It matters if you're trying to remove bad behavior, preserve a fix, or keep a model updated without accidentally undoing earlier work.
I love that this is basically the model version of, wait, did my settings save? Except the settings are facts, behaviors, and safety fixes.
Exactly. It sounds small until you imagine a pipeline where teams are layering updates over time and assuming the old edits are still there. If fine-tuning can quietly erase them, then model maintenance gets a lot trickier than people hope. So yes, this is a technical paper, but it's also a very human one. Everyone who has ever lost an edit knows the feeling.
Across today's stories, the common thread is control. Control over cost, control over workflow, control over access, and control over where AI becomes useful enough to pay for. Anthropic is pushing hard on vertical products and cheaper agents. Google is tightening its tooling around developers, and OpenAI is making the access story part of the product story. The next phase of this market is looking less like a single model race and more like a battle over operating systems for work.
That's the signal for today. The race is widening, and the companies that win may be the ones that make AI feel less like a demo and more like the place work actually happens. Stay curious, stay informed. See you tomorrow.